Hello everyone, very good afternoon. The topic for today is how to orchestrate the DevOps tools together. How you can bring in different DevOps tools together. Let us begin with understanding what DevOps is, friends, first. What are the different tools in DevOps? Then we will see how to orchestrate them together, friends. Of course, that is important, right? And how can we orchestrate and how many tools can you orchestrate is also the question. What do you understand by this term called as DevOps? Currently, there are projects which are being built. The current process, the current model, is this not sufficient that industry is all talking about DevOps and DevOps tools? Why? Let us see that, friends. Let us see that in today's session. So, friends, before I move on to the slides, let me quickly talk about what is the current process. What happens in the current process in current organizations, why we are all looking towards DevOps. So, friends, I'm sure all of you are very well aware of a software development lifecycle, SDLC, right? First and foremost, before SDLC, let us say application. What is an application? What is an application? Application is a piece of code that provides you a feature, a requirement which your user has given. You have built that application to give you a functionality to the user. That is an application. Now, applications are of different types, like desktop applications, web applications, embedded applications, mobile applications. We all know the development of these applications. Let us specifically talk about embedded applications. All the e-commerce applications, let us say, take this example. Let us say you are working in an organization. In your organizations, you are developing this application, e-commerce application, let's say. With this application, so many features you must be building, like order, products, right? And payments, right? Payment gateway, registration, and so on. You will have different sections or different features, we will call them, or we will call them different services that you will be giving to your user friends as part of this application. Correct? Let's say 4 features you are providing to your user. How will you build this application? How do we build this application? Right? There will be 3 things, friends, 3 major things in any application that we have to give to the user. 3 major components: development, testing, deployment, right? Development, testing, deployment. You will use different SDLs. You will use in any development we are doing, any small feature also we are developing, we will use the SDLC process. Software development lifecycle will be used. The different phases that you have in the development lifecycle are: first, you will code. You will write the code based on the requirements given to you. Then you will test. I'm writing on a high level, friends. You will start testing them, friends. After you have tested, you are going to set up the environment, your production environment or any other environment where your actual end-to-end testing should be conducted. So operations, right? And then you will deploy. Once you have deployed your code in the production environment, you are going to monitor. Right? These are on the high level. These are the 5 phases of any development lifecycle you do. Right? Writing the code, testing the code, deploying the code, monitoring. Operations is setting up of your infrastructure, servers on which you are going to deploy your code. Right, friends? So far, we have been, from when on IT industry has been into picture, we have been following this SDLC process. But this SDLC process is implemented in different models in the industry. Earlier, some years back, we used to work with waterfall model. Any application that you want to build, you will go with a waterfall model. That means each of these phases will be built step by step. First development of all the features will be completed, then testing of all the features will be started, then deployment will be done for all the features together as one single application. Of course, we all know the default challenges and difficulties we all had in the waterfall model, right? Mostly we would find the defects, user defects will be there at the end of the session, end of the deployment only we would get to know the errors. Secondly, only small projects we would like to go with waterfall model. Big projects will be difficult to deploy using waterfall model because any changes cannot be accommodated during that model. Right? Any changes means we have to again raise new request, new project request has to be raised. So these were some of the drawbacks with the waterfall model. So waterfall model was used very commonly in most of the organizations earlier when the applications were small, simple, not many features were there. Okay, simple applications, small projects we used to go for waterfall. But nowadays, friends, we have applications which are embedded applications. They provide authentication, authorization, security. They provide persistence data, right? And session data is maintained. Plus, there are hundreds of features coming in with the application. It is not possible to go with the waterfall model when your application is complex. We are all talking about microservices now. Small services given to the user, right, friends? So when microservices is in the top, waterfall model is not suitable. So the industry moved on to agile, friends. Industry moved on to the agile model. What is agile model? I'm sure you all know. We all have been working in agile model. I myself work with agile model for very good amount of time. Agile is also called as an iterative model, friends. Iterative model. What happens in iterative model? Each service or each feature is taken. Let us say first order feature will be taken. Right? Order feature is taken. For this feature, friends, what do? We will develop the code. We will develop the code. Developers will develop the code. They will develop the code, friends. After the development is completed, testing team will sit with them and we will test the code, friends. Now here, friends, in this particular agile model, what happens? Development team and testing team, they work together, friends. Dev team plus test team, they work together. QA team and dev team, they work together, friends, here in agile model. Right? In this, we call something called as sprints, friends. It is a 2 week or 3 weeks development phase wherein we develop the feature. Each feature we will take the feature, develop it, test it. So developers and testers are working together in this particular model, agile model. And then after the testing is complete, this developed code is shared for feedback with the user, friends. Right? Once the user gives a go ahead, all right, friends, awesome. Developers, you have developed it correctly. Testing team, you have done it correctly. I'm happy with this code, with this feature. Go ahead and deploy it. Only after that, deployment will be done. Right? Similarly, let us wait for the deployment. I will write it later, not right now. Similarly, let's say next feature will be started. Then after 2 weeks, next feature will be started. Products feature will be started. In the products features, again, you will do the development. You will do the testing, and then there will be a continuous feedback given to you by the user, friends. User will tell, okay, products feature is also okay, or any changes are there, they will reflect the changes to you. Right? Here, friends, in the agile model, there were certain tools used by the teams. Like development teams started using build automation. Testing team started using test automation tools to quickly deliver the product, quickly give the product or the feature to the user. Okay, but friends, what happened? Even though the feature was developed within time given to the user, but deployment did not happen. Deployment did not happen in the agile model. Deployment was only at the end. After all the features have been built, only at the end deployment happened. Right? The reason is, here in agile model, development and QA team are working together for continuous development, continuous testing. But deployment, the support team, deployment is taken by operations team. Okay, or we also call them as support team. Right? So who all are members of support team? Network team members, your virtual machine, people who provide you virtual machines, your ops team, people who do the deployment, people who take care of your servers, DB admins, your security team, they all are part of operations. Right? Now, friends, in agile model, the disadvantage was, though the development and testing was happening in small features and small phases, any defect is there was fixed immediately, and it was also presented to the user for approval, but the deployment happened only at the end. Though the development happened quickly, within 3 weeks you had the development, but deployment happened only after all the features were developed. Right? Again, in deployment here, friends, no tool was used by the team. No tool was used by them, no automation tool. They went with the legacy way of deploying the deployment by manually installing the servers and manually installing the deployment scripts in agile model. No tools were done, no automation was there in deployment phase also under agile model. So in agile model, dev and QA spoke to each other. They were aware of each other's difficulties, but the deployment team were not aware of each other's difficulties. They were not concerned about their challenges. Okay, all right. So then the challenges were what? Suppose we had to set up the infrastructure for let's say order feature is built using Java. So for deploying the order feature, Java is available in production environment. Products feature is built using Python. Python is not available. Changes have to be done on the servers, or new servers have to be brought up to deploy the products feature. These updates have to be done by the operations team, and they will take their own time to provide the required infrastructure in order to do the deployment. That will take good amount of time, friends, because no tool is there, no automation is there. Manually they are going to do the setup for the virtual machines, install the operating system, install the servers, and then deploy the application, do the QA activities, and then bring up the servers in the production environment for the users to use. This is the legacy way. This is the current way wherever in the organizations you are using agile. Because of which there was a delay to the users, friends. Because of which there was a delay to the users in giving the application. So then came into picture, friends, DevOps, friends. Came into picture DevOps. With the DevOps, friends, we are not making any changes in the current project. You can, with this session, I want you guys to just ensure this particular line is clear to you, that the DevOps is not one single tool, friends. It is not one single technology. It is not a team, friends. DevOps is nothing but your development team plus your QA team plus your operations team working together, friends. Working together. Your DevOps is nothing but dev team, your QA team, and your operations team working together. So DevOps is development plus operations. It does not mean you are doing development and operations by separate team. No, the same dev team is going to do the development, same QA team is going to do the testing. But in your agile model, the same agile model, you are also adding operations. So that means when you are developing the order feature, here also you can take the same iterative model. When you are building the order feature 1, you will start the dev activities. Parallelly, your operations team will start setting up of the infrastructure needed for order. Like if they need a Tomcat server, on that they need Java 8, on that they need certain framework. Operations team is also going to start working. So testing will get completed. Then friends, operations team is going to start deploying. Immediately deploying it as it is fixed. Get it approved by users and then deploy it. Deployment also will happen. Then start feature 2. Start the development for it. Start the development for it. Do the testing for it. Then give it to the user for approval. Then give it for deployment. Everything will happen in one go for every feature. Microservices, take each feature, develop it using a separate technology, deploy it immediately on a server. Microservices architecture, friends, is what we follow now. And DevOps is, I'm not saying any new team member is going to start working on it. The same development team is going to work, same QA team is going to work, ops team is going to work. Now here, friends, if they are same people only, the same people are working, how is it that you will now be able to deliver your product quickly? Because when we talk about DevOps, we are saying that we are talking about faster delivery, quicker deliveries, quality product is being delivered. Because friends, DevOps definition says, stop using the traditional way of software development and start using automation tools. Automate all the manual processes with the help of tools that you have in the market, and for a better velocity, at a faster velocity, you deliver your product to the customers. Start using tools for manual processes. Now, it is your task as a DevOps admin, as a DevOps engineer, if you join in, it is your task to look into your project. What are the manual processes? In development, what are the manual processes? In testing, what are the manual processes? In deployment, what are the manual processes? And change them and start using tools. Implement tools to automate those processes. Thereby, you are implementing DevOps. We have nowadays, every day we have scrum calls, right? I'm sure everybody of you know, we all have scrum calls every day at 9 a.m. or 10 a.m. as per your project. Who all are part of the scrum calls? Developers and testers and product owner and the scrum master. But if you have DevOps, you are implementing DevOps in your project, you are following the DevOps model, then even the ops team is going to be part of your scrum call. They will also know what development team is doing and how they have to set up their infrastructure. They have to be ready for the deployment, right? And each feature will go at one go with help of tools. Now, with DevOps comes into picture one-click deployment. One-click deployment. That is what is goal for today's class. One-click deployment. What do you mean by one-click deployment? That means with the one click in one of the tools, you are going to use an integration tool. With just one single click, your code has to be deployed, your code has to be built, it has to be tested, and it has to be deployed in your servers. With the DevOps, it is very much possible to orchestrate multiple tools together to do the deployment difference. Okay, so this was a quick introduction from my side. Let us move on to the slides. Now, friends, let us see here, friends, different tools that DevOps provide. What is the definition of DevOps? DevOps says start using tools and automate every step of your project, friends. Every step of your project. Okay. Now, friends, these are the different phases of an SDLC which we spoke: planning, code, build, test, deploy, operations, and monitor. Now, in each of these phases, friends, you can use different tools to manage your code. If you are into the development team or if you are writing a code, now you should start using Git or version control tools like Subversion, Bazaar, Mercurial. Git can be used, GitHub can be used to manage your code. Every phase that you see here has a tool, friends. Can you see this slide? Have a look at this slide, friends. Okay, each phase has different tools associated to it. But what is important? This part is important, friends. See, in agile model also, we have been using these tools. Like as a developer, I have been using Git, I have been using Maven. As a tester, I have been using Selenium. As an ops guy, maybe some of you must have been working with containers, so you have used Docker or Vine, right? Or you would have used a Puppet. If you have been into industry for some time, you would have been using Puppet for configuration management. Or if you are if you are into monitoring and administrator, you must have used some monitoring tool for sure, like CloudWatch, Spulk, or Nagios, or Prometheus, or Grafana, any tool you would have used. But have you used all of them together? Have you used all of them together? No, right, friends? With DevOps, we do this process, friends. Using an integration server like Bamboo, Hudson, Jenkins, you can integrate all of these tools together so that your code can be picked up from a source code repository. It can be built, that is converted into a Word file, JAR file. Its test cases, it can be tested thoroughly. Once there are no issues, it can then be deployed using containers in your infrastructure, friends, and then can be continuously monitored using monitoring tool. In case of any issues, the mails or notification can be again sent back to the development. This process can be achieved. This process is called as DevOps. Every team member should work together to integrate their steps, friends. Okay, only one person, administrator, will be there who will take part of integrating all of this code. That is also a scenario in many industries, friends, many organizations. Okay, with this, friends, comes into picture few terms, which is continuous build, continuous testing, continuous deployment, continuous delivery. Let us talk about it quickly, friends. Version controlling, friends. What is version control? With this, friends, with all of these four things, I'm also going to talk about the slides that are coming in later. Okay. First, we will talk about version control. These are also principles of DevOps, friends. Okay. So first principle of DevOps is version control, friends. Version control is maintaining your source code. With DevOps, friends, is coming up multiple tools. You have to write code, friends. Whenever you're talking about tools, it's all about coding. Anyone, developer, ops team or testing team, if you are using a tool, you have to write the code to manage the tool. It is not a front end. Very few tools are coming up with a front end with a GUI where you can just click, right click, or click on the button to perform that. All of these tools with DevOps are command line tools. You need to know some scripting languages, some programming languages to use these tools, friends. Okay, one such a tool is version control tool, friends. What is version control, friends? Version control is three things, friends. Who is writing the code? Where is the code maintained? And what changes did you do, friends? Right, friends. So today I have written some piece of code. Let us say it got deleted. Okay, or let's say we are people of 10 team members. 10 of us have written the. All of that code is available at a shared drive. Now, who wrote which code? What changes made by developer 2 did mess up the entire, or maybe there was a fix given in the source code. Right, there was a fix given in the source code. Who gave that fix? Which developer gave that fix? Did that fix spoil the entire code or no? Did it mess up the code? Suppose you deleted few lines of code, okay, and you want to get back those lines. Is it possible to get it? In a notepad you write few lines, you remove it and save it. Once saved, it is permanently deleted, right? Those lines are permanently deleted. You cannot get them back. But friends, DevOps says that start using version control tool, start maintaining your source code in a version control tool. One such a tool is Git, friends. Here, let us talk about it. Git is an open source tool, friends, where you can maintain your code. Not just the developers, but the ops team also will maintain their infrastructure code, their containers code. Okay, this Git, friends, anybody can use Git, friends, or one of the any organization. If you see here, so many organizations are using Git. These are very few, but every other, even freelancer developers and organizations, startups are using Git to maintain their code, right? Let me show you. Let me show you a structure here. Now, what is a Git, friend? Git is a distributed version control tool that will allow you to contribute your source code at a common location. Let us say we have 6 developers working here, friends. Or even your team members. It doesn't mean only developers, testers, and ops team. Now here, first user, he will maintain. This is his laptop, friends. This is his laptop. He's written some code here. He will maintain his code in this remote repository. This remote repository is called as GitHub, friends. I'm sure all of you have heard about it, GitHub. All of the team members can contribute their code at a common location called as remote repository. The code contributed by dev1 or user 1 can be used by user 3 also, friends, because it's a common repository, anybody can access it. The advantage here, friends, is the Git here tracks every change that you have done to your files. Every user, whatever change he has done, they will track, Git will track it, friends. That is one advantage of it. Right, friends. Okay, so let me show you one of the example in Git wherein one of the organizations is maintaining their source code on GitHub. So I have queried this project to Git. It's available on GitHub. This is the remote repository, friends. GitHub. In this GitHub, if you see here, these are the different contributors. If you see, 1400 contributors are there to this project. With Git, friends, you can get to know which contributor added what pages, okay, to this particular repository, friends. Let us take this repository. Okay. Let me go to the one second. Let us go to the project only. If you will see this source code, Basically, friends, we maintain the code in the form of branches. Like development team will maintain their branches, testers will maintain their branches. I think I'm not in the correct project. Just give me a minute. I went to the users project here. Okay. So this organization has 1400 contributors to this repository. See here, we maintain branches. Maintenance branch, next task to be assigned, seen, reviewed task, to do task, right? And if you go to each of these folders, let us say, or if you go to any of the folders here, in the folder, friends, you can find out what are the changes and who did what changes. That is what is tracked by the GitHub, friends. Here, Git generates a commit, which is like a transaction. Okay, it gives you what changes, who did what. See here, some lines, the green color shows that the new lines which were added by this user, right? Red color will show what lines he removed and what date, what time he did it. That details also will be there, right? So GitHub is a version control tool which keeps track of the changes that are done by each user to the source code. Thereby, first of all, you have a common repository where all of your source code is present. Once you have a repository where all your source code is, you can manage the source code, right? You can pick up all the source code from here, build it and deploy it, right? You don't have to manage it on your local server, right? This is a common repository. You can see each developer what changes he have done and you can manage their code also. See, these lines were removed, these were added. Tomorrow, if you want to get back the code, you can always get it because Git tracks everything. Git is one such tool which helps in continuous version control. Right? User will write the code, add the code. User will write the code, add it. Continuously, they will keep adding it to the GitHub. Okay. The next thing, friends, is next thing which comes into picture is, friends, continuous integration, friends. Continuous integration. Continuous integration is nothing but taking the source code, taking your source code from where? GitHub. So other version control tools are Mercurial, Subversion, but Git and GitHub are most commonly used. But GitLab is also coming up in the market. Now, next step is after your code is available. What is the next step, friends? Once your source code is available, what is the next step? Correct, friends. Absolutely right. We will build it, friends. Building is nothing but compiling your source code, reviewing the source code, unit testing the code, and finally generating a WAR file and integration testing and end-to-end testing of the source code. Right now, friends, you take some source code and you compile it, you develop it, you review it and you test the code. All of this can be done with an integration tool, friends. This cycle of automating the process of picking up your source code, compiling it, and unit testing it, and generating a WAR file is called as CI, friends, continuous integration. I'm sure you all have heard CI/CD pipeline. CI, continuous integration pipeline. Let me show you this with a demo, friends. Basically, we use continuous integration tools like Jenkins, friends, to implement continuous integration. So this is the front end of Jenkins. Okay, I will show you if I have a pipeline job here. Okay, so using a pipeline, friends, you can take your source code. Okay, I have a source code given. I'm picking up my source code. Okay, with that, friends, you can take the code. Check out here means it's a stage. So using Jenkins, you can create stages, friends. It's an integration tool which will pick up your source code from GitHub. It will compile your source code, review your source code, unit test it, and package into a workflow. Everything can be done with one single tool called Jenkins. One-click tool is Jenkins, friends, which will help you to implement continuous integration. Now, how are these steps executed? You must be thinking. Build automation tools like Maven, MS Build, PyBuilder, Gradle, and these are used, friends, with Jenkins to perform compilation and generating a build. These are developers tools, friends. They use it. We as a DevOps, if you are using Jenkins, developers will help you with the commands to integrate them in Jenkins. So I'll execute this pipeline and show you what I have done. If I show you here, I've written some code here, friends. In this code, what I'm doing, I'm creating stages. I am taking a repository here, friends. My class code repository I'm taking, and we are trying to compile it, review it, and test it. See how will it get generated. Okay. So this is also called as orchestrating multiple tools with the DevOps. With this, with Jenkins, friends, I'm orchestrating 3 tools, friends. 4 tools. First is Git, from where my code will be picked up. It has just completed, picked up the code from Git. Okay, you can see the output here. Compile the code. See here, it picked the code from where? From Git. It picked up the code. Then, friends, once the code has been picked, it is using Maven. It is using Maven to execute the code, friends. Compile the code. The tool that is used next is Maven, friends, to compile. MVN here represents Maven. Okay, to compile the. Once compile is done, what is the next thing it is doing? It is reviewing the code. That is also done. Once it has reviewed the code, right now it is trying to execute it. Okay, my slave is offline. It's going to fail. Okay, no problem. It is going to fail because I am trying to execute it on a slave. Okay, unit testing is being done on a different machine, and then it will metric check it and package it, friends. Then it will package it. Okay. Okay. Now this, all of this can be done with Jenkins integration. This is called as continuous integration pipeline, friends. CI pipeline. Now what is CD pipeline? It'll take some time to execute. Let it complete. Next, friends. Delivery and deployment, very important thing. Continuous delivery, continuous deployment, friends. Let us see the difference between them. What is continuous delivery? What is continuous deployment? Very easy, friends, very easy to understand. I will just show you with the diagram here. See, friends, you will have you have multiple environments, right? Dev environment is there, test environment is there, staging environment is there, and then you have your production environment, right? Correct. Okay. Now, friends, see here. If you are using Jenkins, I will take Jenkins only as an example. Let us say any integration tool you can take. Jenkins is the most commonly. If you are using Jenkins to compile your code, to test your code, okay, once the testing is done, you have to do deployment. Okay, you have to do deployment. If you are using Jenkins to deploy your code, the tested code in the staging environment, okay, till the staging environment only, it is called as continuous delivery. Using Jenkins to pick up the code from Git, okay, compile it, test it, and then deploy it into your staging environment, UAT environment or staging environment. That is called as continuous delivery, friends. Continuous delivery. Okay, this is called as delivery. Okay, next, friends, suppose you are using Jenkins, the pipeline code which I just showed you, friends. If you want to run such pipeline code, that is to pick up the code from Git, test, compile it, that is build it, test it, and then deploy it into the staging environment. If in the staging environment you will do a testing, if testing has passed, after that deploying it directly into the production servers also. If you are using a tool to deploy your code into the production server, is also, then it is called as deployment, continuous deployment. Many organizations are going with continuous deployment. Many of them are going with continuous delivery, wherein the deployment will happen manually. They will take this downtime, or the request will be raised with the users to get the downtime, and on the specified date, deployment will happen. Okay, that is continuous delivery. But if there is no such a requirement, immediately as you will click in Jenkins, your pipeline will start, pick up the code from Git, build it using Maven or any build automation tool, test it using Selenium, stage it, deploy it in the staging environment, complete the testing, and then deploy it in the production server. That is called as continuous deployment. Next thing is, how do you do continuous delivery and continuous deployment? So there are tools like container orchestration tools and configuration management tools, friends. What they do, friends, container orchestration tool, let us talk about it now. Okay, let me quickly go there. We have seen Git, we have seen Jenkins, and I have also shown you pipeline as a code. Now, Selenium is a tested tool, friends, which will help you to execute your test cases. Okay, using this automation tool, you can do your testing on different browsers. And you will here is where you need a programming language, either Java, Python, to write your scripts. Okay. Now I was talking about continuous delivery, friends. That is Docker, friends. Using Docker, you can do your deployments, friends, you as a container. Earlier, friends, we used to use virtual machines. On virtual machines, we would install operating system. We will install a Tomcat server or Apache server or Nginx server, and then over that we will deploy our application. Gone are those days, friends. We now do everything as containers, friends. What are containers? What are containers? Three things you need to understand here, friends. Containers are nothing but images, friends. Okay. Let me tell you this thing. Suppose, let us say, I'll give you a very simple example. Let us say I have a user, okay, and let's say that that's myself, and I have created a code. I've written a code here using Java 8. I have written a code, okay, an application code I have written here in my laptop. This is my laptop I have written, and the operating system I have used is CentOS 8. Let's say I've used CentOS 8 for it. Okay. Now one more friend of mine comes in and says that, hey Sonal, I also want to check your application code is written correctly or not. I also want to write few features into it. Give your application code. Okay, so what will I give him? Will I give him my laptop or will I give him everything? No, right? I will just give him this application code. I will build this application code into a WAR file and I will give him, or I will give the source code only to him. Right? Right? So what will happen? My friend, let's say the user 2, let's say he has a Windows machine. Okay. On the Windows machine, he has Java 10. Okay. On this, he placed my application code. On this, he got my application source code and he is trying to run it. Will it work, friends? Give me a quick yes or no. Will this code work here? On his machine, he has Windows, he has Java 10, and he has got his application code over here. Will it work or not work? No, right? It will not work. It will, of course, not work. Right? It will not work. We will get environment dependency issues. Environments are not same. Java 8 is needed to run the app. Java 10 is available. It will not work. So what should my friend do? He has to create a virtual machine, create the operating system, CentOS 8, install Java 8, and then run the application. Instead of that, there is a much better option available in the market, friends. What we can do, I can, in my laptop, whatever operating system I have, does not matter. Just I will install Docker. Okay, and I will create my application code using Java 8, whatever it is. I will write the application code. With the help of Docker, I'm going to create a package. A container is what we call. I'm going to create this package. In this package, I will tell what operating system I need. In this package, I will also put down the application code Java 8. Okay, for programming. And I will also put my app code also I will place. This is the package one. We call this package as an image, friends. Image is what we call in Docker. This image I will create, friends. Now my friend comes up, developer 2 or user 2 comes up and says, let it be whatever is there in his machine, it's okay. He just needs Docker on his machine. Okay. And he will say, hey Sonal, give me your code. I want to run your code. I will give him this image. He just needs to run this image. Application will be successfully deployed. He will be able to access my application from his browser without any issues, because the image has all the dependencies. Container is a process which has its own environment, its own network, its own libraries, resources, and your application code. That image, when run, will create a container. Container is nothing but a running instance of your image. These containers are lightweight and you can create them within seconds. Okay, so nowadays everyone creates such images for their services. For every service you can create such image, and in production service you just run these images. So the infra teams don't have to do any dependency setup of the environment. They just need a Docker on their laptops, on their servers. Docker is what they need, friends. You need to know which image to run on the Docker. Correct. That base knowledge is needed. Okay, friends. Now, friends, after this, I have one more question. So this is the same thing. Okay, I must have used this diagram here. Same thing. Earlier we used to use, okay, we used to create such virtual machines over which you can now run your containers. Using the image is what you create your containers now. Using these images is what you create containers. Docker Hub is a library where you maintain your images. From Docker Hub, in your staging server, you can pull that image, run the image in your staging server, and then if the testing is done successfully, you can pull the same image and deploy it in your production server also. Containerization is a platform which will package your application, its dependencies together in the form of your application, in the form of an image. You place that image in a Docker Hub. It's a repository, friends. Pull the images from there to deploy your application. For this, you need Docker on all the servers. You will need the same Docker, no, same Docker version will be needed. Even at least you need that Docker which supports that image. Yes, every user should have a Docker to run the images. Docker images are platform independent. Now, friends, I have one more question here for you. Now the question comes to you all is, the question which comes in, we have created an image. Okay, we have created an image for the application. Let's say the image name is app. Okay, you want to deploy it. Okay, in your infrastructure, if there is only one, if there are only 3 servers, let us say there are 3 servers in your infrastructure. On this, you want to deploy your application. I told run your image on all these servers. Run your image on all these servers. Your application will be available. Provided on all the servers, you should have Docker. Right? This is what I just explained. On all these servers, you should have Docker. Here also, you should have Docker. Run this image. Run. Where is this image? Image will be in Docker Hub. Your code will be deployed successfully. You will be container will get created, and your application will be available for you to access. Okay. For this, we have multiple concepts in Docker, friends, like port mapping, volumes, Docker swarm. Okay, Docker compose. Different concepts are there in Docker to implement. How we can implement this? It's not possible to explain in one class. Okay, let us say in 3 servers you were able to deploy your application. Now the question comes in infrastructure, you have 100 servers. On 100 servers, you have to pull this image and create a container. How will you do it, friends? How can we do it? Manually, is it possible? No, friends, not possible. You have to create 100 servers. On 100 servers, you have to run this image. You have to install Docker on all those servers. You have to start Docker. You have to pull this image and create a container. These 4 steps you have to do on 100 servers. Is it possible to do it with manually? No, not possible, friends. So for this comes into picture called as configuration management tools, friends. Configuration management tools are tools which will allow you to set up your infrastructure, allow you to write code to set up your infrastructure, to install packages, to create files, to create images, to create containers on multiple servers at one go. That is configuration management. There are 3 tools like Puppet, Ansible, Chef, which are the most commonly used tools in the market, friends. Puppet, Ansible, Chef, friends, are the most commonly used tools in the market that are used for configuration management. Puppet being the oldest tool, which is the most commonly used configuration management tool, but it is an open source tool. It works on master slave architecture. Here the agents pull the configurations from the master machine and apply them. Now let me show you. So we write in this over here, as you see, we write code here on the master machine. This code is written as to what changes do you want to do on your slave machine. Okay, and the slaves will pull those code and apply the changes. Let's say you want to create a file on your slave. You write the code here, Puppet will pull the code. Every 30 minutes it pulls the code and that file will get created. These slaves can be from 100 servers to 200 servers. On all the servers, file will get created. One single code you have to write here on the master machine. Okay. One such important tool is Ansible, friends, which I really like and everybody likes to work. In Ansible, friends, you write playbooks, friends. Playbooks are simple codes written in YAML, which is a file format, not a scripting language. Using this, friends, using Ansible, you write the code on Ansible master machine, which then the host pull in to make the changes. Okay, I will show you a demo of this. Okay, so here, friends, and I maintain you can maintain the code in your, let me stop this guy. One second, friends. It will go into error, so let me just delete this build. Just a second, pause it. Okay. All right, it's continuously playing it, let it be there. Now, I'm going to do one more thing. This is the last scenario, continuously orchestrating all the tools. Now, friends, if you see, I have created a playbook. This is an Ansible playbook, wherein, what am I writing? I've written a code here in YAML, friends. The code here is very simple to understand. I'm sure you all can understand it. I'm installing Tomcat on my servers. I'm having a group of web servers, friends. Some 50 servers. On all those 50 servers, I want to install Tomcat. I want to install Docker. I want to start Docker. Then I want to pull my source code from a repository. There is some repository available. I want to pull the source code from the repository. Once I pull the source code from the repository, I want to build an image. I want to build a Docker file, that means build a Docker image. And then I want to run the image to create a container. Once a container is created, I will be able to access my application, friends. Now my application name is address book, friends, and I'm going to show you the deployment for it right away, live, friends. And this deployment is going to happen on multiple servers, friends, not just one server, multiple servers. A group of hosts that are part of my web servers. Okay, I'll open one server and I will show you. I think it should be up and running. So this is my slave machine, Ansible host machine. Okay, and friends, the advantage here with DevOps is you are going to create or run this entire setup, installing your servers, installing the packages, deploying your code, picking up the code from GitHub, deploying it. Okay, everything you're going to do through Jenkins with one single click, friends. I have written a pipeline code here, friends. I have written a pipeline code here, which is going to pick up your code. Okay, it is first going to pick up your repository from Git. It is going to clone the repository, and then it is going to run that playbook for you, Ansible playbook. So in my Jenkins, friends, what have I done in my Jenkins? This is what I'm doing, friends, just to show you. I am integrating Git. Okay, let me use this for faster access. I'm integrating Git with Maven, with Docker, which will create the containers, and with it Ansible, because Ansible is going to do the deployment and Docker containers, where you're going to use Docker to create the containers, but Ansible is going to deploy it on multiple servers. All of this is going to be triggered through Jenkins, friends. Now, friends, let us execute that pipeline, and you will see that I will just run this pipeline, and you will see that, let us build this. It's going to pick up the code from GitHub. It is going to pick up your Ansible code also from GitHub. Okay, and this playbook, if you will see here, every step will be executed one by one. First, it will pick up everything from Git, and see here what's happening. Installing Tomcat, starting Tomcat. On all the servers, it will do that. Installing Docker, starting Docker, cloning the repository, build the image, container created. Container has been created. Let us see if on one of the servers, I will log into one of my servers and I will see if there is a container which got created. Right now, see here, 21 seconds ago, there was one container which got created with this image. And what is the, let us try to access the application. So this is called as continuous deployment, friends. In Jenkins, I can add a trigger that if there is any change, 1 minute, friends. If there is any change on my source code, automatically this job should run. Got it, right? My application is deployed. I can deploy it anywhere. You guys also can access this application. I'm giving you the link. Try to access it. Okay, you guys can also access my image. Okay, so here friends, you can also go to your Ansible playbook and set a trigger that execute this playbook every 1 hour. Execute this playbook if there is a change in the source code. Execute this playbook every 15 minutes, right? So your source code will be continuously being deployed on your servers. Continuous deployment, CI/CD pipeline, right? I hope you have enjoyed today's session. Thank you so much, friends. Bye-bye, everyone.